Okay, here's the notes on the heart part two. You just showing some of the review from yesterday. So we have our heart's kind of split into four different sections. We have the two atriums, they're up top, again, and the ventricles on the bottom. And they're separated by like the AV valves and our semilunar valves as we go through. The aorta is what carries all the blood around to your whole body. You have the oxygenated blood, and then the vena cavas, superior and inferior, bring that deoxygenated blood from the body, and then that blood is then pumped to our pulmonary artery, which takes the blood up to the lungs and comes back through the pulmonary veins into the left atrium. Cardiac catheterization. Okay, back in the day, doctors had to rely on external symptoms to detect coronary artery blockages, okay, which then people had to have a lack of energy, rapid breathing, couldn't sustain physical activity, things like that, in order to actually see if any of these coronary artery blockages are happening. The same symptoms can also indicate a variety of other circulatory and even respiratory issues. So now doctors can use a few different techniques to actually help narrow down what is going wrong with the patient. So one of these techniques is called cardiac catheterization. Basically, this is where a small hollow tube, which we call a catheter, is passed into an artery in the groin, okay, and passed up through the aorta into the heart. Okay, a dye is then injected into the catheter, which that travels through all the vessels and can be viewed by a fluoroscope and projected into a TV screen. Basically, it's highlighting the blood, and so then you can see it on the TV screen and how it moves throughout um, the body. Yeah, this technique shows where there's reduced blood flow prior to surgery, so then the surgeons can actually know where to go in and fix. Okay, a surgeon can then use the catheter, which has a tiny balloon attached to it, to inflate the blocked blood vessels. Okay, so this is called angioplasty. A second technique that can detect a blockage is to get a blood test. And then the heart, it really differs from other types of muscles. The cardiac muscles have a branching pattern that can contract without being stimulated by external nerves, so myogenic muscles. This is why the heart can beat even when it's removed from the body. The heart of a frog was removed and put into a salt solution. When stimulated, the muscle continued to beat. Each part of the heart beats at a different rate. We have our ventricular muscles beat slower than the atrium. The muscles closer to the vena cava has a faster tempo, and the tempo of the heart is set by our sinoatrial node or SA node, which is a small mass of tissue, and it's actually located in the right atrium. This acts as our pacemaker, which for our heart that sets the amount that beats. So those certain people, like if this isn't working for them, they have to get a separate pacemaker put in that actually makes their heart beat up to a certain rhythm. Okay, nerve impulses are carried from this node and then to the muscle cells and causing them to beat. Okay, the contractions travel to the atrioventricular node, and this serves as a conductor, passing the nerve impulses through the Purkinje fibers, through the septum, to the ventricles, and up the outer walls, and then back into the atrium. Okay, so our nodes either in the atrium, okay, and they send these um, signals throughout the heart and then to the AV node. The AV node is connected to these fibers, which cause the heart to beat, or the muscles to close or tighten. Both the left and right atria contract before the left and right ventricles. Okay, the sympathetic nervous system increases the heart rate during times of stress or when it's stimulated by different chemicals. The parasympathetic nervous system slows the heart rate back down to a normal pace. The lub-dub sound the heart makes is caused by the closing of the heart valves. When the heart is relaxed, it's called diastole. Okay, and this is where the atria are filled with blood when relaxed. When the atria contract, the AV valve opens and the blood flows into the ventricles. When the ventricles contract, the AV valve closes and the semilunar valve opens, pushing the blood into the arteries. When the AV valve shuts, it makes the lub sound, and when the semilunar valve closes, it makes the dub sound. And so when the heart is contracting, it's called the systole. Sometimes the valves don't close completely. Okay, this is one of the causes of heart murmurs, so then they don't get that same lub-dub sound. Okay, the heart murmur can occur when blood leaks past a closed heart valve. The AV valve, again, the atrioventricular valve or bicuspid valves, are especially susceptible to defects. So hearts with murmurs compensate for decreased oxygen delivery by beating faster, which again, as any muscle, as you work it more, it's going to get bigger, so the muscle actually enlarges. Okay, another way the heart compensates is by taking in more blood in the atrium, which increases the pressure, pushing more blood to the ventricle, which then pushes more blood into the arteries. Okay, I'll post the link for this video separately in our Google Classroom. Okay, just showing kind of the heart. This is showing all the different fibers that cause the heart to beat, like our nerve fibers. And we can see some of them as they go through. And some of these, like this, is our pulmonary artery, so it brings the blood through.